So, hello everyone. Today we are going to solve yet another problem in Atiyah and Macdonald's book. So, we are going to solve problem 5 in chapter 3. So, the problem 5 says that we are given a ring and for any prime ideal P of A, this local ring AP has no nilpotent elements. Nilpotent elements. So we have to show that A has no nilpotent elements. So this exercise kind of says that having nilpotent elements is a local property, I think. But to say this, I need to make sure that if A has nilpotent elements, does that imply that A not having nilpotent elements, does that imply that this AP has no nilpotent elements? Like, is this thing true? Does this imply that AP I think this is true, because if AP has a nilpotent element, then this means that we have A or S belonging to AP, where A belongs to A and S does not belong to P, such that A over S to the power n is equals to 0. For some S belongs to S, this means that A n over Sn is equals to 0, which in turn implies that A n times U is equals to 0 for some U not belonging to P. And so I'm trying to show that if AP if I'm trying to show that if some AP has a nilpotent element, then A must also have a nilpotent element. Hmm. Hmm. Well, the problem doesn't actually ask that if A not have an nilpotent element, that implies that AP has no nilpotent element. It asks us to prove that the reverse implication is true. But just out of curiosity, I was trying to see if this thing is true, because this would then imply that having nilpotent elements is a local property. So let us first prove what the problem asks us to prove. So suppose A has a nilpotent element, then we know that A belongs to P for every P belongs to P prime P. Um, mm, we have to somehow show that some AP has a nilpotent element. How much time are we in at this point?